Okay, this is lesson 6-5, Exponential Growth and Decay. So the first thing you're going to do is write this formula down, but write out beside it or above it, whatever you need to do, that this is the exponential growth function, because we're going to have a few other functions we're looking at today. So for exponential growth, we have y equals a times 1 plus r, and then that is raised to the t exponent. And then if you want to go ahead and draw with these like little lines, what each of these means, you can. So y is your final amount, your answer. A is your initial amount, the amount that you start with. Okay. R is the rate of growth in decimal form. That sounds confusing, but all that means is you may get a percent. So for example, 5%, but it wants it in decimal form. So you would move it 2 times, and that would be 0.05. That's all that means. And then T is the time. Okay, so we're going to go ahead and look at an example. So it says the inaugural attendance of an annual music festival is 150,000. The attendance Y increases by 8% each year. So we have two parts. A, write an exponential growth function that represents the attendance after T years. Okay, so we're going to set up our function. And then B, how many people will attend the festival in the 5th year? Round your answer to the nearest 1,000. Okay, so first thing we do, if we go back up and look at that, we have y equals a times 1 plus r to the t power. So you look at what you were given. The inaugural attendance of an annual music festival is 150,000. That just means that's basically the typical amount that they have. That's our initial amount. Okay, the attendance y, what we're solving for, increases by 8% each year. So 8% is our rate of growth. So we will put it in decimal form. And it just says after t years. So we're going to have y equals, because that's what we're solving for, 150,000, because that's that initial amount that we have. Then we have times 1 plus, and our r becomes 8%. Change it to a decimal by moving it 2 times, 0.08. All raised to the t power. So that is our exponential growth function, but we can simplify it a little bit. We can't do it much because we don't know what t is. So 1 plus 0.08 is 1.08 raised to the t power. That's all you do for part A. You're just setting up that function. Part B says how many people will attend the festival in the 5th year. So we're just going to solve using the one we have for the 5th year. Now, only part about this that's might be a little confusing. Let me make sure. Yep. Is that when it says 5th year, the first year that it happened would be year 0. It'll make more sense once we get to another problem on why that starts out 0. So the 5th year would technically be 4. So for example, if we had, let's see. So if they said in 2011 was when it started, okay, how much would it increase by year 2014? So you would look, okay, from 11 to 12 is 1, 2, 3. So even though it's 11, 12, 13, 14, 4 years that you're talking about, it's only a 3-year difference from the beginning to that point. So that is why when we plug in for the 5th year, our t is going to be 4, not 5. So we would plug that into that formula. So we're going to have y equals 150,000. I may just look at theirs so I don't have to type that part because my handwriting on this is not the greatest. Okay. So right here, this is what we have. This was our final answer on A. So for part B, we're just going to take, and for T, plug in a 4. So we raise that to the 4th power, then times 150,000. And we are going to round just because it's hard to be exact, and we don't have an idea. This is more of an estimate. So about 204,000 people will attend the festival in the 5th year based on that exponential growth function. So you're going to try one. says a website has 500,000 members. The number of Y members increases by 15% each year. Write an exponential growth function that represents the website membership T years after 2016. And then go back and B, how many members will there be in 2022? Round your answer to the nearest 10,000 because it is an estimate, so you're going to round. So pause the video, try that, and then I will go over it with you. Problem number 1 was a word problem. It said a website has 500,000 members in 2016. The number of Y members increases by 15% each year. So for A, write an exponential growth function that represents the website members T years after 2016. So our initial formula, and I realize you can't see that super well, but it says Y equals A times 1 plus R to the T. A is the initial amount, R is the interest, T is the time in years. So we just go back and plug that in. So the initial amount it said was 500,000 members. So that is my A. Parentheses, I have 1 plus R, it said after, or increased by 15%. So we put it in decimal form, so you move it 2 places, so 0.15. And T is time in years, and it just said after T years. So T. That would be part A. Then for part B, says how many members will there be in 2022? Round to the nearest 10,000. Okay, so the first thing we have to do, the reason, and I think this problem is great on helping us understand why the first year is 0. Because from 2016 to 2017 is just the first year that it happened. So you have to wait till you get to 2017 before T is 1. Okay, because you can't say it's been a year when you just start something. It has to be a full year before you can count that as 1 year that's happened. So from 2016 to 2017 to 2018, 2019, 2021, and 2022. That would be 6. So we just go back. I take that equation to the 6th power. And we can solve that. 1 plus 0.15 is 1.15. Then I have to the 6th power times 500,000. Okay, so we do get, let me just go ahead and write this all so I can explain. 0.383. Okay, but it said round to the nearest 10,000. So we've got thousands, 10,000. So we're rounding to this nearest place. 6 rounds up, so that becomes a 6. So it's approximately 116,000. Does that right? Hold on, let me read the question again. How many members will there be in 2022? That doesn't sound right. I don't know. I felt like it should have increased. Let me see if I added that right. One, two, three. Oh, duh. I was like, it should have gotten bigger. I'm sorry, y'all. I just realized I didn't put any of the numbers. I left one out. 1, 2, 3. This one is a 6. That makes more sense. That's the correct answer. Now we're going to look at exponential decay. So exponential growth function, now write down exponential decay function and write this function down. If you notice it looks similar, the only difference is it is a minus instead of a plus sign between the 1 and the R. Everything even stands for the same thing. You have your final amount, the initial amount, the rate of decay in decimal form, and T for time. So we saw this one the same way, it's just now we have minus R instead of plus R. So first example starts out, it says determine whether each table represents an exponential growth function, exponential decay function, or neither. So what we do on this problem is we look for a pattern, okay? So on A, if you notice on the X side, it goes up by 1. On the Y side, it's being multiplied by 1/3 or dividing by 3, okay? But you would say multiply. So dividing by 3 is the same thing as multiplying by 1/3. So it's multiplying by 1/3 on this side. So since x increases by 1, y is being multiplied by 1/3. That would represent exponential decay. Basically, if you have to divide to get from one number to the next, it's getting smaller. So that is an exponential decay since it was the same number each time. Okay, so then on B, we're adding 1 on the x side and on the y side 5 times 2 each time. Okay, so as x increased by 1, y was multiplied by 2. So that is exponential growth. Okay, an example of one that would probably be neither could be if you were just, I'm trying to think of how to word that without confusing you. Actually, I'm going to have you try one and then we'll talk about that. Okay, so let's do just number 2. I'm not going to make you do both of these. Try number 2. Pause the video, try it, and then I will go over it with you. Okay, on problem 2, we are having to determine does it represent exponential growth, exponential decay, or neither. So what we do is we just look. On top, we are adding 1 each time. On bottom, it goes from 64 down to 16. So that's either subtracting or technically dividing by 4, which means we'd be multiplying by 1/4. And that is what happens each time. So since it is a fraction, this is exponential decay. And as x increases by 1, this is just how we explain it. Y decreases by multiplying by 1/4. So since it's getting smaller, that is decay. On example 3, now we're going to be interpreting exponential functions. So it just says determine whether each function represents exponential growth or exponential decay, and then identify the percent rate of change. So they just want us to identify R as a percent once we determine if it's growth or decay. So if you notice, this is in the right form as far as y equals a, either 1 plus r or 1 minus r to the t power. It's simplified. So you just look inside these parentheses. We have 1.07. That is bigger than 1, which means it had to be 1 plus r inside parentheses, not 1 minus r. So that means it's exponential growth. So just from looking at that, we know it was exponential growth. Then to solve for r, we just take what's inside parentheses and we say, okay, well, 1 plus r equals that number, and we solve for r. So I subtract 1 from both sides to get 0.07, and they want it as a percent. So you move your decimal 2 times. So it has r equals 7%, and it was exponential growth. That's all you do on this. So on B, if we're looking at it, it's already in the right form. So I'll look inside the parentheses, 0.98. That is less than 1. So that means this is exponential decay, which means they had the 1 minus r in parentheses. So we take 1 minus r and set it equal to what's in parentheses and then solve for r. So we subtract 1 and then we have to divide by that negative to get that r is 0.02, which means we then have to move the decimal to get that it is 2%. So it was exponential decay and it had a rate of 2%. Okay, now let's look at the next example. Rewriting exponential functions. So we have to rewrite it to then determine if it is exponential growth or exponential decay. Because if you notice, it's got more going on up here than just t. So we have to rearrange it to get it to just the t power, so then we can determine if it's growth or decay. So t over 4, we've done a lesson previously where that meant you have t as your exponent, but it's 1 over 4, which we know to mean the 4th root. So we just take that and plug it inside the parentheses. So t over 4 is the same thing as saying 0.96 to the 1 over 4 raised to the t power. 0.96 to the 1/4 power, that's saying the 4th root. comes out to 0.9898 and so on, but they went ahead and rounded, so it rounds to 0.99. Now it's in the right form. Okay, we have one number outside, one number inside to the t power. So being that 0.99 is less than 1, we know it represents exponential decay. That's all we're having to do on this, is rearrange it or simplify it to then determine if it's decay or growth. Okay, so for part B, I think I can actually just stay there. It says f of t equals 1.1 raised to the t minus 3. So we have to kind of really pull back the last lessons. Whenever your exponents are subtracted, that meant it was division with the same base. So that's like saying 1.1 to the t power over 1.1 to the third power, because that meant we would do 1.1 t minus 3. That's where they got that. So looking here, because theirs looks much better than mine, now we can kind of look at solving this. We're going to leave the top alone, but we know for the bottom, that's the same thing. If I were to separate them, 1.1 to the t power, because I want to explain how in the world they got their answer, times 1 over 1.1 to the third power. That means the same thing, because they just took what was being multiplied, the 1.1 to the t power, and put it on top. The reason I'm saying that is because if you plug this in your calculator, so 1 divided by, and then 1.1 raised to the third power, you get a long decimal, but about 0.75. So that is where they got that, and they just put it out front of that 1.1 to the t power because it is being multiplied. Now that we have it in the right form, 1.1, that is greater than 1, so it is exponential growth. Okay, so we're going to try some of these. I want you to do, let's just go ahead and try all 4 of these to get good practice. 4, 5, 6, and 7. Okay, try those, pause the video, and then I will go over it with you. Okay, I'll do these first and then erase it and do the other 2. So on 4, just by looking at it, it's 0.92, which is less than 1, so we already know that it's exponential decay. Okay, so now we just have to figure out what r is. Since we know it's decay, we know inside there would be 1 minus r to get 0.92. So we can just solve for r. Add r to the other side, and you could get rid of the 1 and then get rid of your negative. I'm just going ahead and making my r positive. So then subtracting. So we get 0.08 equals r. And remember, r is a interest rate. So r is 8% on number 4. Okay, on 5, 1.2. That's bigger than 1, so we already know it's exponential growth. So I know 1 plus r equals 1.2. So subtract 1, and we get 0.2. It's a percent, so move it 2 times. R is 20% on number 5. On 6, we can't have that yet when we are trying to determine if it's growth or decay. So when it's 10t, sorry, I can't say that, that's 10t. That means we have this raised to another exponent when we multiply. So I can rewrite that as 1.02 to the 10th power all to the t power. Because remember, when we have an exponent raised to another exponent, we can just multiply them. That's what they did to get that. So what I can do, I went ahead and plugged this in the calculator. I can do 1.02 to the 10th power. I'm going to round it still. And 1.22 to the t power. If you notice this, I'm going to say approximate because I rounded. This is now in the right form. So we can determine, since it's greater than 1, that's exponential growth. And we can just leave it as that. That's all we had to do on that one. Okay, on number 7, t plus 2. If you remember, if you have one thing and your exponents are being added, that means we have the same base being raised to this exponent times the same base raised to this exponent, because when they're the same thing being multiplied, you just add your exponents. That's how they got that. So I can't do anything with that one, but I can solve this one. And I'm going to move it to the front just so it's in the right form. So 0.95 squared comes out to approximately, and I'm rounding, 0.90 or 0.9. And then I still have 0.95 to the t power. It's now in the right form. Since this is less than 1, that is exponential decay. Okay, last section. Now we're going to look at one more type of function, compound interest. Okay, so write this formula down, and I would write what these mean. T and R still mean the same thing that they did previously. Now instead of an A, we have P, which means principal amount because it's interest, and that's still your A, your initial amount, okay? But now we have an added letter, N, the number of times interest is compounded per year. And if you notice, we have N in two places. So whatever N is, you're going to write it twice in your equation. So we have Y equals P for principal amount times 1 plus R over N, all raised to NT power. So let's look at a problem doing that. So it says you deposit $100 into a savings account that earns 6% annual interest compounded monthly. Write a function that represents the balance after t amount of years. So we start with our formula. Then we just plug in the numbers into that formula. So you deposit $100 into a savings account. That is your initial or principal amount. So that is what you plug in for P. Then it says it earns 6% annual interest. So we change that percent to a decimal. So we have 0.06 for R over N. It told us it's compounded monthly. So for 1 year, it's compounded each month. So there are 12 months in a year. So we plug in 12 here. That 12 also has to go up here times T for T years because it didn't tell us how many years. It just said use T. So we do that. You just plug this that's in parentheses in your calculator, PEMDAS. You have to do parentheses first. When you do that, you get this. That would be our answer. That's as far as we can go because we don't know T. Our exponents would have to be next, so we cannot multiply by that 100 yet. It's really just taking the formula and having to plug numbers into it. We're not going to look at graphing it. I don't feel like that's necessary for this. So I want you to try number 8. Okay, and when it says write and graph a function, you're just going to write the function. You're not going to graph it. Okay, so try 8, pause the video, and then I will go over it with you. Okay, last problem, number 8. So it says you deposit $500 into a savings account that earns 9% annual interest compounded monthly. Write and graph, we're not doing that part, a function that represents the balance Y in money or in dollars after T years. So since it's compounded monthly, we're using this formula. So we just plug those numbers in. The initial amount was the $500 you deposit. We have 1 plus the rate, interest rate was 9%. So as a decimal, that is 0.09. So that goes on top because it's compounded monthly. The number of times a year is 12 because there's 12 months in a year. So my N on both of those is 12. And we just have T for T years. That's it. That's all we had to do on that one. So 500 times 1 plus 0.09 over 12, all raised to 12 T power.